Good morning, good evening, good afternoon. Everybody's welcome. I'm speaking from Australia, Sydney, where the time frame is difference is like 7 hours ahead. I'm absolutely delighted to be with you tonight and thanking our colleagues and friends, Dr. Fawzan and Dr. Sarraj, for their outstanding performances in achieving such an events. Tonight, my topic is going to be in value engineering, and this is for lovers and where is it? Where is it? Sure. This is romantic. I'm trying to, yeah. Can you see the screen now? Can you see the screen? Okay, the first slide.
Not yet, Dr. Emad.
Are you sure?
Yeah, share screen again, please.
It's there. Let me put it again. This is screen. This is share screen. Can you see it now?
Yeah, make it full screen, please, Doctor.
Can you see the first slide?
Yeah, make it full screen, please, Doctor.
Full screen. Okay, can you see it now?
Yeah, go ahead.
Okay, so we're going to be talking tonight about value engineering under crisis situations, and probably this for COVID-19, which impacts heavily all over the world. And this is me in brief. Maybe the moderator have no time to go for it, but this is a quick one. I'm teaching value engineering at Western Sydney University and president of Society of American Value Engineers in Australia, New Zealand, and Papua New Guinea and Solomon Island. In addition, being certified value specialist live from the United States and chartered professional engineers. If we go to this slide, just briefly, I'm going to show you some of the projects been doing in the last number of years. This is in 2019. We did value engineering at Sydney University, at Queensland University in Australia. It's still ongoing. In 2018, there was a value engineering in Jeddah, 2018 in Bahrain, Doha, Qatar, Qasim, Saudi Arabia, and Iraq. And these are the percentage savings we obtained. 6.9, 23%, 694. These are the savings we did through value engineering. To do your value engineering in Australia, you have to be registered with a panel. That one called New South Wales panel and SMC 1191, category 328, to become a value management facilitator. To start with, I can't see my audience from here, but I would assume that there is some novices, some beginners and the other are professional. So I would assume that there is some people who know nothing about value engineering. So I would start from scratch. So value engineering can be defined as a methodology, is a systematic process used by a multidisciplinary team to improve the value of product through the analysis of its functions. What does it mean? That instead of looking for elements, we go for functions, and we will see an examples coming soon. And this is a kind of specialized work with the team that focusing on what are the functions doing in the buildings or the projects or in the items. So we have another definition here: specialized cost control technique. Again, value engineering is not it's not a science like mathematics or chemistry or physics. Neither sorry, neither than it's science either like physics or chemistry or chemical engineering or mechanical engineering, which performed by a group of independent and highly experienced individuals. We consider those guys are a third party to check and examine the validity of the design and the quality in order to achieve the functional balance between quality, performance, and cost for any project, system, or facility. So, to understand value engineering for those who are coming new to this kind of field, you have to understand the pillars, the 5 main questions in value engineering. These are, what is it? The question number 1, what is it? And when we said what is it, I need full descriptions of that items. If it is a column, you have to say to me, it's a concrete column, structural column, circular sections, square, rectangular, 40 by 60, made of concrete, blah, 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 blah. So you're gonna give me a full description of that items. If it is HVAC, air handling unit, air chiller, plumbing, you should describe it fully. The second question is, what does it do? When I said what does it do in value engineering language, it means what is the function? Why the designer designed this item? What is the purpose? What is the function of that item? So if we go to the example, the column, so what does it do? Column carry load, support load. We often in value engineering language, we have to use verb and noun, just 2 verbs. There is no sentencing or paragraphs. No, very simple. If we have a car, what does it do? Transport passenger. Pen, make marks. Air conditioner, control temperature, etc., etc. The third question is how much it costs. When we said how much it costs, we have to refer to BOQ, bill of quantities. How much that item was given to me by a quantity surveyor or cost engineers who at the early start of the projects who assigned this one. You have a projects, you have a bill of quantities, all the items given by QS or cost engineers. So that one, when I say how much it costs, that columns, for example, it will cost me $5,000, $2,000, whatever. The fourth question is how much it's worth. Here is the tricky questions, which is value engineering. When I said how much it's worth, exactly what is the cost that deserves the function doings. I'm not talking the elements, I'm talking the functions of that element. So when I said what is the worth, it means the value engineering alternative, the value engineering alternative or the solutions, okay? And we'll see that one in a minute. Then value index at the end of the questions, we divide the worth over the cost, and it should give us ideally number, which is number 1. That means that the designer is not over-designing or overestimating the cost. Okay, now value engineering and projects overview is divided into 3 stages here. If you look at the left slides here, we have feasibility study and planning. This is one of the stages of the projects. The second is design and constructions, the second. And the third one is operation and maintenance. So at the first stage, value engineering can be here, okay? At the design making, we check how good or how bad is that design. Is it successful or not successful? Is it feasible or not feasible? So we have attributes. We have return on investments, we have break-even point, we have payback period, we have internal rate of return. These are the 4 attributes or the 4 indicators, which tells us exactly from the early beginning that if we can go as a feasible project or not. Once we finish that one, we move to the second, which is design and constructions, and we could check that value engineering fits over here during the design stage. And we have 3 stages over here. We have conceptual design, which poses something like 30% or 40% of the design. Then we have another schematics up to 60%, then design development up to the 90 or 99 before bidding. So that works the impacts or the validity of value engineering at that stage at the design review. Later, or finally, we go, as we call, operation and maintenance. For the total cost, this is, we have an initial and running, and value engineering can be used at life cycle costing, and we check during the running cost any replacement, any maintenance, any repairs, it can be added or avoided during the study. So if we take an example here, for example, let's take an electrical cable here. This is electrical cable. So what is the function of that electrical cable? Conduct electricity. Okay, the function is, as we said, verb and noun, just verb and noun, conduct electricity. So the original design, it was copper wire. So the cable at that time, it was used by copper wire. And that cost me 5K per ton dollar. So what is the worth or the alternative? The alternative is aluminum wire, which do the same functions, conduct electricity, but it cost me 4K per ton. Okay, so when we find out or work out the value index here, it's function analysis divided by function cost. So the function worth divided by function cost, 4 by 5, it gives me 0.8, which is exact, nearly 1. Okay, so this is the value and the value index. How can we manage the value in the projects? We have to choose the right team. This value engineering team for any projects or any study, it has to be headed by what we call team leader, the guy over here, which has a certified value specialist. This is the post-nominal by United States American Society of Value Engineers, while in other places like Australia, they call it value management facilitator, or in the UK and Europe, they call it professional in value management, or value manager in Japan, you name it. But this is the head or the team leader, works with team members like mechanical engineer, civil engineer, structural architect, and cost engineers, with coordinator with clients. The slides here shows us the process or the methodology. Like any other management techniques, Value engineering has a process which contains 5 steps. The first step is information gathering phase, which I, as a team leader, ask the client or the one who hires me in the first instance to do this job, that I need all the information which supports the study, like the drawings, price, bill of quantities, geotechnical reports, environmental reports, copy of specifications, copy of contracts, permissions, anything that relates to the projects, I need it in my study to fulfill the requirements. Second, we start with step number 2, what we call it function analysis phase. And that one, we go for the cost analysis or BOQ, and we analyze every items in terms of functionality. What is it? What does it do? What is it? What does it do? Let's assume that we have 2 types of BOQs at the moment. One we have CSI, the other one is Master Unit Format, and you can take each system by system or each item by item, and we analyze it functionally. What does it do in terms of functionality? Third, we have what we call creativity and idea generation phase. This is we go and do some what we call brainstorming and try to find out some ideas which supports our analysis for creativity and functionality. So instead of the column, do we have to do other options? And we will see it soon in these slides. So instead of this one, we have another options. Then when we have finished from brainstormings and we collect ideas, these ideas has to be evaluated in different categories or different criteria, selections. And later on, once we evaluate and we get the succeed or the passing one, which gets a score 8 and above out of 10, that one moves to the second stage, which is development phase, and we give it further investigated solutions or studies. Finally, when the last day of the sessions or the last day of the workshop, we combine all these ideas, developed ideas, and we show it to the client's representative who hires me in the first instance, and we tell them that we have solutions or alternatives by VE, which saves you this amount of money. That ranges from 5 to 10 to 15 to 20% of the total cost. So these are the methodology. Again, this is, we have a pre-workshop, then the workshop, which we said is 4 to 5 days, then the implementation stage when we go back to the consultants and he fixed the alternatives and re-amend some of those ideas to give us the savings. Okay, let's do some exercises here or examples. This is in Australia and Hornsby, one of the train stations, and I'm showing the double glazing here, glass of sheet or sheet of glasses, which is much higher than it should be. This is the height of the man or the woman or the traveler, and maybe it's 1.5, and this is up to 4 or 3.5. So it's a bit exaggerated or over-designed, probably unnecessary. Okay, if we take this buildings, for example, this is also in Sydney. You can see this part of structural or decorative items, which I don't know exactly what's the function of it, except that extra money is added for the clients, which has no basic functions to support the buildings. What I mean by basic functions, I mean that if we take this one out, the building will not collapse. This is not a foundation, this is not a columns, this is not structural elements. Similar here, these are columns, which I believe is something like make a beauty or something for make the building appealing and attractive for the customers. Similar wise here for some buildings, which you never know what are the functions. There is no logo, there is no theme, there is no nothing except extra money is added in the shoulder of the clients and later on to the tenants and buyers. And again, the columns, which is unnecessarily being very close to. Again, this is one of the buildings here. You could see this part, which again, I don't know why the architect is placing or adding it. And I ask maybe so many people in my lectures and my seminars, no one knows, and people start guessing, maybe, perhaps it looks like, which is not acceptable in VE. Let's take another example here. These are the columns you can see. And I'm gonna take two examples. One here, this pergola, and the columns, and we'll see it in the next slides. Okay, so as an engineer watching me now here, we have this sequences of columns, and every engineer, structural, civil, or whatever, he knows exactly that when we go up, the loads in the top decreases. So why the diameters are the same? Either he should decrease the diameter of the columns because the load here is almost nil or very minimal, except that kind of horizontal roofing. So he could have avoided this items which cost him probably $2,000 or $3,000, I don't know. In other solution we'll see it, because this is non-structural. This is okay, we agree that this is structural. It carries horizontal load and it carries a vertical load, but this one not. So maybe if we use this value engineering alternative solutions, we could have avoid these columns, and we go for L-shaped supporter, which could be fixed here through nails or bolts and nuts in the wall, or it can go through the dangling cables over here. So as long as this is not a heavy stuff and just resting on that idea, so it's not a column here. Okay, and we can save up to 5 to 10%. Also for the columns, the sequence of columns, these are the ones. It's 40 diameters for the column all over the top, while the load is decreasing on the top. So this is the solution. The first one is 40 centimeters the diameter. The second one is 35, then 25, because the loads, the vertical loads are often decreasing when we go to the top. This is another example here. It's one of the ugliest design I've seen, that the architect, he is placing a column over here, which costs him $1,500. He could have go and used the cables from here. Two cables, wire cables, no need for this columns. Even it's precluding and stopping and blocking anybody coming from outside and he wants to enter with some stuff, heavy stuff into a house. So these are the kind of design we are facing. So this is what I'm talking about, you see. It can be used like these cables, and it carry this kind of pergola or kind of elements here. No need to place or implant any columns which it will defame or defile the shape of the buildings. This is a case study I used to study it in Sydney for Opal Tower. It's a high-rise buildings, which there is a problem in floor 4 and 10, and the tenants start to leave the building when they feel that there is unsafe. It's a big story. You could go to the internet and find out, but my concern here is I want to show you clause 14 at the final report, and it says that we should assign somebody who is third party to check and certify the engineering design, which means value engineering. The final few slides is regarding certification and qualification for value management or value engineering. You have to have some courses and study to be qualified for this kind of certifications to practice in this country. In all over the world, we have two schools. One is in the United States. They call SAVE International, which Society of Value Engineers, which imparts or awards certificates like AVS, the old one. Now they change it to VMA, Value Management or Value Methodology Associates, and CVS, Certified Value Specialist. This is in one hand. On the other hand, in Europe, Asia, Australia, they have another post-nominal or recognitions, training value management, value analyst, value methodology facilitator, and different one. Now, the most important slides, which our concern today is during the crisis, during the COVID-19, what was the creativity imposed or related to the value engineering. This is my issues or points, crazy ideas. Yes, during the lockdown or during the siege, embargo, you name it, a lot of ideas, even as crazy and ridiculous, is coming out, and we will see some of them. But you never know. Sometimes we don't underestimate any ideas, which maybe it turns out to be a good idea. Internet browsing, very important nowadays. You have to go and check on the internet. China, United States, Singapore, Iraq, Egypt, Saudi Arabia, almost everywhere. You would find some people who are becoming very creative and innovative during this crisis or during this lockdown. Storytelling, listening, often every time with the YouTubes, internets, snapshots, anything, you would have heard very clever and very interesting story about people creating something or innovating something. And this is because they concentrate a lot while they are blocked between four walls, and they are not too free to go anywhere, but to concentrate and squeeze minds and brainstorms. Watch video on YouTube, human behavior, multicultural sports. We are in Australia, in a multicultural country. You find so many people from different countries. And if you sit with them, they will tell us exactly different stories about how did they manage, how did they cope with the COVID-19, how they did with this kind of restrictions and siege and paracade. Everyone has his own story. For the new technology, drone. In fact, drone is doing good for me. And this is my drone, which I using it. I hope you can see it. This is my drone, which I used to fix things while I'm sitting in my room, like maintaining lights, overheads, doing things here and there, horizontally and vertically. That's one of the creativity we use in value engineering, that this kind of things, it could go and helps people while they are restricted areas and they can need helps. For the last two items here, non-engineering educated persons. Sometimes you need to sit with non-engineering personality. I mean, to sit, even old people, young people, non-engineering people, because sometimes end users have a lot of stories in his mind. So maybe one of them is solving your problems. Finally, innovation, exceptional, overwhelming. These are the kind of trigger, and these are kind of issues we need while any crisis that impact you. So don't sit at home, don't sit doing nothing. Try to use your mind, squeeze all these ideas coming in your mind and try to make something useful instead of gaining overweight or gaining some weights in your tummy and later on become sorry for that kind of restrictions. I think these are the last slides, references, and I believe that maybe this presentation can be delivered to you later on if you want to take it from the organizers. And I'm ready for any questions. Thank you very much. Thank you.
Are you listen? No?
Yeah, we are listening. Doctor, you're on mute. Please mute yourself.
We can't hear you.
Hello?
Hello.
Yes, okay.
Hello? It's okay now?
Yes, okay now, Franco.
Oh, thank you very much. I'm sorry, I'm the moderator. I don't know if
No.
there is the second speaker or not. Is able the second speaker?
Yes. Yes, I am willing now.
Okay, Mr. Hossam, Dr. Hossam, please. It's your time.
Yes.
Go ahead, your
Yes.
speech.
Okay. Hello. Good morning. Hello. Good afternoon. First of all, I would like to thank the moderator, Doctor, and Dr. Fuzan, the chairman of the boards of the Arab Operation of Maintenance Council, and also for IMA. My speech, it will be in a smart green maintenance of building. This is the first what you said about green maintenance, and I am a member board for Omantic. My speech talk about smart green maintenance standard and indicators, smart green maintenance costs, stage of smart green maintenance, measuring the sustainability of building, smart green maintenance technology features, smart green maintenance technology field, smart green maintenance technology strategies, smart green maintenance technology for tomorrow, smart green maintenance application. We will show the definition. It means green maintenance is a composite of 3 words: green, maintenance, and smart, and green. It means green maintenance is that is free from using that is harmful to the environment. Whatever for building material that are used to replace as a result of damage or damage, and what is the connection of the elements calls for also the use of health maintenance tools is far from any product of manufacturing that violated the environment. Green smart maintenance is a desirable methods and modern methods with a high technology, desirable and interaction and dealing with its requires in order to improve the preservation of the existing or heritage building, and it preserves the environment as well as security and human safety, and it's applied to the buildings, whatever, residential or building of other use. This is a very important to use the smart maintenance, because if we talk about building, I try to say this building, it's like a human. It can help, it can feel, it can exist, but it not to give us an impression. After it's not like a human being. If you feel harm, you can express by voice or by sound or by feeling, but for building, no. But for the smart dimension, it's the use of the age of technology. Can you give the second slide? Second slide. In the highest fraud application, whereby the value and the performance of any components can be determined, whether it is a validity and when it can be replaced or improved. Smart dimension is one of the innovations of the current era where technology and computer are used. In each various program, we can use the program for PIM, building information modeling, to put all the data of the building and to know each part by giving you a signal or a word that there is a harm of the building in this part. And the operation system is the correct reading on which the evaluate the success of work and maintenance. The smart maintenance system follows the high efficiency and the quality software to achieve operational occurring and also adjust the performance. From that way, you can measure everything, every part of the building to know the performance. What is the percentage of the performance of the building, and guide operating economies. That means you can reduce also the cost of the maintenance according to all this data. Therefore, we had to update our methods and dealing with the maintenance in a way that does not affect our environment and keep it in more than good condition.
Hello?
Mental with modern technology, and modern technology means of modern programs and tools that can analyze and monitor
Hello, we don't listen.
information and various
Hello?
and treatment methods. Yes, you are with me. In the last time, at least time using environmental friendly material and natural methods compatible with the environment and non-harmful to harmful or construction. The principle of a smart maintenance, which is very, very important to talk about the smart maintenance, are summarized follows by developing a system to maintain reading performance indicator for all system and building elements using a computer. This computer, it can be mobile or iPad or by computer in a screen, and to use the personal mobile. Focusing on system and determining operating capacity, safety, and economy are the main criteria. Consider design constraints, continuous reporting and follow-up are essential for improvements. Any unsatisfactory performance, maintenance operation must be carried out on a legal base. And I give here a short principle of a smart green maintenance. That means if the building is smart for the structure, for using energy and electricity and HVAC, also for material smart environments, smart for management facilities and controlize, smart maintenance, that means it will be a good matrix to control the smart green maintenance. These indicators, second slide, please. Second, indicator of for measuring the performance of a smart green maintenance quality. These indicators for measuring the quality of a smart maintenance performance are the tools through which the building life can be known and its implication for its residents, and it's a very indicators, the definition, the dimension that determines the activity of building after its maintenance, and also defines the method of maintenance. Let's stop for this point, and we talk about smart green maintenance should be first for the design stage. We can use all this data and put it for the consultant to put it in consideration when he make a design. When the submission, the first submission for the work, we have to control that. And after that, the third stage for the operation. This intelligent performance measurements indicator, it can help for the time useful. Yes. Useful life of building elements, operation economic, maintenance plans and operation methodology, smart uses and quality control. Second slide, we talk about green smart maintenance standard and indicator. When talking about smart maintenance and green maintenance, there must be criteria to measure its performance, measure its performance, and this topic has been addressed by many research contents, and the evaluation system must be as a lead and prim, and the indicator for measuring performance for smart maintenance. The elements to be evaluated are arranged as first indicator related to sustainability and related to the impact of raw material and maintenance practice on location and transportation, the circumstance and the envelope of the building, water quality and efficiency of use, energy efficiency and climate. All these elements can be effective for the building, and also as items for maintenance, raw material and natural resources, quality of life and building user experience. Second, indicator related to smart maintenance at its quality, duration of the repair of the manufacturing, the time period between the breakdown and others, quality equipment, alignment with preventive maintenance plan, percentage of performance performed for the plant maintenance. All these items can be effective for the costs. And we talk about green smart maintenance costs. Innovation technology in a smart building greatly reduce operation and maintenance costs thanks to their ability to collect and analyze data, which was previous inaccessible. In additional, the sensor placed. That means we can put some sensors for all the infrastructure and the connection to know and to measure the performance. This can be automatically programmed in maintenance activity, which present fails. Predictive maintenance is 3 to 9 times cheaper than any interaction damage and already occurred. Moreover, with smart building management techniques, owners are informed for potential problem before the equipment actually fails. That is alarm and give a sign before any problems. Can ordinary citizen deal with the maintenance for small building? That's very important. That means it's not only for professional. Any citizen, any ordinary citizen, in the modern concept of maintenance, citizens have no role in maintenance, not even in reporting errors. The process is completely automatic, and any problem is solved before its occupants become aware of it. Moreover, techniques involved in interfering with the building will not waste time searching for information to solve the problem thanks to thermal imaging or infrared. For example, the building manager will be available to detect any device that is outside the temperature range. This data can be easily discovered in advance. That means it's a preventive maintenance started from this point. It's not a correcting maintenance. That is a problem for the meaning, because now all the people work with correcting, not to preventive maintenance. Before the device cuts of the system, another example, it's detection, electric transmission lines, which have holes or holes produce ultrasound. This can happen unnoticed in normal situation, but with lot technology, the technique can easily locate it, the exact location that needs maintenance to intervention. Having said that, it is also true that the success factor in technology innovation lies in the degree to which the users accept it, treat that affect their daily lives. So it is important to engage user early and familiarize that with the smart technology to be implemented. We talk about stage of green smart maintenance, connecting with building with a communication network. In this step, most building will be transferred and their data prepared so they can be succeed through smartphones and computer from anywhere and anytime from outside the building. You can control the maintenance and to get the data far of the place. We start this step by converting building system into electronic control system, modernization in this approach that must be followed, and we cannot continue to build a smart and modern building and wait for you to replace. Yes.
Thank you, Hossam, because time is really over. Thank you. As a moderator, I would like to say
2 minutes.
Do you have 30 seconds? It's okay?
I have to. Yes.
30
of course,
seconds
to give
close.
Yes. Here's a strategy. If you go through the slides for a strategy of technology, the smart green maintenance, we talk about the technology completely based on a group of material that is for the green, and for the smart using the computer and everything related to the calculation. And we are going to talk about green smart maintenance and technology for tomorrow. This is a very important to put it in future, to take care for these assets and to take care for your costs. And there is so many applications. Thank you very much. But this is a pioneer.
Thank you to you.
We're out anyway.
Thank you to you. Just one consideration for the excellent presentation of Emad, that is putting our attention to consider the value of the facility. And I would like to add not only the design value, but
Mr. Franco.
Yeah.
We out of the session now.
Can I use 30 seconds or not?
We can talk together only here, but we can. The attendees already cannot see us.
So I can stop here.
Yeah, you could stop here and we can say goodbye and thank you for your joining.
Thank you also.
Thank you so much.
And thank
you very much.
Have a good maintenance. Thank you. Bye.
Thank you for you.
Thank you, doctor.
Yeah, bye-bye.